We are indeed going to pick up right on where we left off with this particular lab, but I want to show you something on Router 1's Show IP Protocols output first, and something we're going to change in the config. And it's this particular line, Automatic Network Summarization is in effect. I have a lab coming up in this section that shows what happens in many situations when you leave this on. It is almost automatic that you're going to turn this off. It's so automatic that you're going to turn it off that a lot of people think that automatic summarization in RIP is off by default, but as you can see, it's not, it's on. So I just need you to take me at my word right now that it's really important that we disable this because it's going to mess up our routing tables. It's going to get a little confusing. And when we do our automatic summarization lab later in the section, you'll see exactly why. But right now, I want to show you exactly how we're going to do that, turn it off that is. And the full command is no auto summary, and there is a little dash in there, a little hyphen. You'll see this as no auto so often in books, labs, practice exams, maybe even the exam. So you really should be used to that. But again, if you start seeing some screwiness in your routing tables, you're not seeing the subnets you think you ought to see, it's probably because auto summarization was left on. Again, got a full lab that's going to show you exactly what's going on there. But for right now in this lab, I do want to turn auto summarization off. So let's hop down to router 2. And router RIP, we're going to do a version 2 and a no auto. And now we're going to enable RIP on our loopback interface and also on 172.12.123.0, our serial interface. And that's it. And we'll go over to router 3. You know the commands here, I'm sure. And now that we've enabled RIP on all our interfaces, and we have the version agreement, everybody's sending version 2 updates, everybody's receiving version 2 updates, let's go up to router 1 and see what we can see. First off with Show IP Protocols, because we should see something different here now, and you can see that we do under Routing Information Sources. And you will see the address of the source. You will see something called a distance again, and we've got a distance here of 120, and we're going to see it again here in a moment. I promise you we're going to cover that. But it's also going to show you how long it's been since the last update came in. So let's go ahead and run show IP route, and we'll see if we see these routes. And there they are. And they're right there at the top. And also, notice that a RIP route is a RIP route. You may occasionally see a default RIP route, but as far as all these other different kinds of routes we have with EIGRP and OSPF, as you can see, we have quite a few. A RIP route is just a RIP route. So you're going to see R here, and that is it. So we see our subnets, and there's that number 120 again in the brackets. We are going to cover that. The second number in the brackets is always going to be the metric of that particular path. And the reason I'm mentioning that, of course, with 1, we know what that is. It's 1 hop. This is RIP. What's the highest that number can be without the route being taken out of the table? 15, right? Because if that were 16, it would be considered a poison route, or rather an unreachable route, and it wouldn't even be in the table. Let's go ahead, though. What do we need to do before we leave router 1? We need to ping those addresses, because as we saw in the static lab, just because you see them in the table doesn't mean you can ping them. So let's go ahead and ping both of those. First one goes right through, and we're looking good so far. So let's head back to the diagram for just a moment. And now we're going to see if R2, one of our spokes, can ping the other spoke's loopback, and then we're going to ping router 2's loopback from router 3. First off, though, we got to make sure the entries are in the table. So let's head to router 2, and you can see the RIP table here, though, only shows 3330 because, of course, 2222 is a connected network. So let's go ahead and see if we can ping there. And looks pretty darn good. Let's head over to router 3. Just want to get you used to these filters, because show IP route, certainly nothing wrong with that. And you'll also notice that with some iOS versions, when you run a filtered routing table command, you get the full routing table, the code table. Sometimes you don't. And the key here, though, is that your codes, or your routes, I should say, your routing table can get so big. I mean, it's going to be bigger than one screen. So sometimes you don't want to look at every single route in your table. You just want to look at the RIP routes or the OSPF routes or a particular route. And here I just ran show IP route RIP to filter it and only get the RIP routes. Very handy little command. Let's see if we can ping 2222. And we can. So that looks pretty good, but let me ask you something. Let's go back to the diagram for a moment. We talked about the rule of split horizon, and that rule states that a router cannot advertise a route out an interface if that's the same interface the router learned about the route on in the first place. Easier to say, right? But we have the rule down. So in this case, why is it that router 1 can successfully advertise, say, router 2's loopback down to router 3 if router 1's advertising that route out the same interface it learned about the route on in the first place? And let me put some numbers with that to restate it. Router 1 is learning about router 2's loopback on serial 10. That's the only interface it's even talking with right now, so that has to be it. So router 1's learning about loopback 2 there via serial 10. But then it's sending an advertisement to router 3 the same way, same interface. How is that happening? Well, that's the one default I mentioned. I know I'm throwing a lot of stuff at you, so I want to remind you of this. The one-time split horizon is disabled by default is when you are dealing with a serial interface on a frame relay network. And that's exactly what we're doing right now. So that is why router 1 is able to advertise the routes, the loopbacks, out the same interface that's learning about them on in the first place. But what if you wanted to turn that off? What would it look like if we did that? You're going to see exactly how to turn split horizon back on and what the impact is on the routing tables at the beginning of the very next video.